For this last section, we're going to talk a little bit more about complex numbers. So we're going to be working again with that letter I a little bit, but we're going to be doing operations with complex numbers. So we're going to kind of take a step away from dealing with the quadratic formulas again and like quadratic form and talk about that imaginary number I. And operations means that we're going to talk about what happens if you try to add it, subtract it, multiply it, and those kind of things. So the first thing I want to go over is if you're trying to graph complex numbers. Remember when we were talking about quadratic formulas and equations and we were actually trying to solve a quadratic and we got those imaginary numbers, that's when it never crossed the x-axis, and so it either sat above the x-axis or it sat below, and it never crossed that line. But we talked about that there's not real numbers or real solutions there, they're imaginary. So because it can still be graphed, we have to talk about like where are the imaginary numbers and if we graph it. So we've got something called the complex plane, and it looks like this, where you've got the same like kind of x and y axis happening here. The x-axis is going to represent your real numbers. So like 1, 2, 3, -1, -2, -3, those are your normal numbers. The y-axis though instead is going to be representing the imaginary numbers. So that's where your i's are going to be. So if you have like a 2i or a -2i, or even just I and -I, those are going to be on the imaginary axis. When you're graphing imaginary numbers or complex numbers, you want to go, think about like when you guys graphed a coordinate, you always did the x movement first and then the y. So if it was like 3, 2, you guys would go to the right 3 and up 2 and you drew a point. You're going to do the same thing for these, but you have to think about moving the real number first and then the imaginary number. So we're going to practice graphing first. So for this first one, remember this is the real and this is the imaginary axis. We're going to go -3 on the real axis. That means you go left 3. Now it's 0i. That means that there's no imaginary unit to this. It's the same thing as just -3. So we're going to just put a point right there at -3. I'm going to call number 1 a. So I can put a little a next to my point. That way if I go back later, I can follow where I was at. So I'm going to call b for number 2. 3 is going to be c and 4 is going to be d. Now 2 just has the imaginary part, no real part. It says -3i. So instead of going left or right, we stay at 0, 0, and then we just go, for this case, it's -3, so we're going to go down 3, and that one also is going to be on the axis there. We're going to call that point B. So can you guys tell me what directions do you think I should go for number 3? 4 plus 3i. Right, 4. And then 3i, it's positive, so we should go which way? Up, 1, 2, 3. So there's C. Okay, you guys try to do number 4. -2 plus 4i. So you guys should have gone left 2 first, and then up 4. And that's the next point there. So, yes? Nope, you won't have to connect the dots to make shapes. Nope. Okay, so now that we know how to graph them, we should then be able to be given a graph with points and name what they are. Be able to count the real spaces and the imaginary spaces. So for this next example, they've given us the imaginary and the real axis here. We've got 4 points, A, B, C, D again. We just want to name what they are. So for A, again, start at the real axis first. So for A, I went to the right 2. That means that there's a real number of positive 2. And then I went up 1, 2, 3 on the imaginary axis. So that's positive 3i. So for point A, it's 2 plus 3i. For B, I went to the left one, so that's negative 1. And then I went down 1, 2, 3, 4 on the imaginary. So it'd be negative 1 minus 4i. The second piece should always have the I attached to it, because that's the imaginary piece. Okay, so you guys take a second and do C and D. And I think C should be right here instead. I think that printed a little bit weird. Should be on the axis. So what's your point for C if it's on the axis there? So negative 3i? I mean, you could write like 0 minus 3i if you wanted to, but 0 is not going to do anything to that piece. How about for D? Yeah, I think it printed weird. It's supposed to be over on the axis. I don't know why it shifted that direction. But yeah, if you actually did the point that C is at, it would be at 0.5, negative 3i. How about D? Good. Negative 2 plus I. All right, so let's talk about adding complex numbers. Now we add them just like we add like terms. So just like in the past when you guys were given like a big set of equations or a big set of terms, and you were looking and you said, okay, all of these are x's, all of these are y's, all of these are plain numbers. You add the like terms just like you did then. So when you're looking at your pieces in this case, if it helps you, highlight or underline like what you think needs to go together. So the real numbers here are the negative 2 and the positive 3. And the imaginary pieces are the 4i and the negative 11i. Now watch your signs here, because it's easy to make a mistake, because they're going to start throwing in negatives and subtraction signs. So you got to make sure that you carry those over. Now this one has a plus sign, so it shouldn't be too bad, because we're taking negative 2 plus 3. So negative 2 plus 3 is going to leave me with a 1. What's going to be 4i plus negative 11i? Good, so it's going to be 1 minus 7i. Now for number 2, there's a subtraction sign. So if it helps you, before you even try to combine, think about this subtraction sign and distribute it into the parentheses. It's going to change the signs of those terms. So we've got 4 minus I minus 5 minus 8i. So that's what I was talking about earlier when you have to be careful with those negatives because they start to change things a little bit. So we've got 4 and negative 5. Those are alike each other. So 4 minus 5 is going to be negative 1. And then you've got your negative I and your negative 8i. So what would be negative, like 1? Negative 1 minus 8. Negative 9. And then I. Just think of those i's right now as like an x. Okay? They're just acting like any other letter would act. I want you guys to do 3 and 4. So for number 3, you've got the 6 and a negative 6. And then you have negative 2i and a positive 2i. So what happened on that one? They all cancel, so you guys should have been left with a 0 for that one. For the second, or for number 4, again, if you need to, distribute that negative into the terms first. So you have 10 plus 3i, and then minus 10, and then negative times the negative 4i is going to make that become positive 4i. So you've got 10 minus 10, that's going to be a 0. But what's 3i plus 4i? 7i. Okay, so number 3 you should have gotten 0, number 4 you should have gotten 7i. All right, let's talk about absolute value of complex numbers. So when we talk about absolute value with regular numbers, we're talking about how far away they are from 0. Okay, absolute value is distance from 0, so whether you go negative or you go positive 5, you're still 5 units away from 0. So absolute value, remember those straight bars up and down on the side of a number make everything on the inside to come out positive. So if it was a negative 5 in the absolute value, it came out as positive 5 because we're talking about distance. And distance can't ever be negative. You can't go to like a lumber store and say, I need negative 12 feet of something. They're going to look at you like you have 5 heads because you can't order negative amounts of things. So you have to have positive distance, and that's what we're talking about with absolute value. Now, absolute value of a complex number is the distance from the origin to the point on the coordinate plane. So we kind of talk about the distance formula a little bit, which you probably saw some of this in geometry when you were trying to find like how far apart points are on the coordinate plane. And this was useful like if you had a shape drawn on the coordinate plane and you were trying to figure out if the sides were the same length, especially if you were trying to prove this shape's a rectangle or it's a square or something like that. So the distance formula is down here again. And that plus sign should be an equal sign. That's a typo on my part. So you have x2 minus x1 squared, and then y2 minus y1, that quantity is squared. All of that is underneath the big square root sign. Okay, so we're going to do the same thing for absolute value. Their absolute value one up here is when you've got those two pieces, the real number piece and the complex number piece. You put that underneath the square root sign, and you're doing your a squared plus your b squared. So kind of combining these two things together, remember that the real number axis is like where your x-axis is. The imaginary number is where the y-axis is. So a is going to represent like your real number part, and the bi is going to represent your complex number part. So if I had 2 points here, I can kind of form like a right triangle where the distance across the bottom here is your a, and the distance up and down is your b. So to find the distance there, think about if this is a right triangle. You guys also in geometry probably talked a lot about Pythagorean's theorem, a squared plus b squared equals c squared. So we can use that in addition with the distance formula to help us figure out the distance between the origin and a point on the complex plane. So to do that, you're still going to have your big square root sign. You're going to take your a minus 0 and you're going to square it. And then your b minus 0 and you're going to square that, which is how they're getting a squared plus b squared, which is what I have highlighted up there in the blue. So this is just showing you how did they get that equation, a squared plus b squared. This is just kind of showing you that process of where it came from. So remember, the a piece is going to be your imaginary number. The b is going to be the number that sits in front of the I. So you're not really going to be working with the I so much. You're just going to be talking about the number that's sitting in front of the I. So like, what's that coefficient? So on the next page in your guys' packet, we're actually going to start practicing this. And if you think it's really complicated, it's actually not that bad. Okay? I'm going to show you. It's actually really simple. You just have to find two numbers and plug it into this equation. So for this first one, we have absolute value of -9 plus I. So the numbers that you're working with are the -9 and the number that's in front of I. What number is sitting in front of the I? 1. So you're also going to be dealing with the 1. So underneath the big square root, you're going to do -9 squared plus the 1 squared. So what's -9 squared? 81. And 1 squared? 1. So this is going to be the square root of 82. And you can leave it in the square root form. You don't have to give me a decimal answer. For number 2, they just have the absolute value of 6. There's no imaginary number piece to it. Now, we probably know the absolute value of 6 is going to be 6. Okay, because you were taught that a long time ago, that whatever number is inside the absolute value just comes out as is. Now, if you actually followed what we did up here, you're going to get the same answer. The real number is 6, so you're doing 6 squared. Now, since there's no imaginary number, there's no I, that means that the number sitting in front of I was a 0. So you're taking this plus 0 squared. So you're going to end up with the square root of 36, which is how we get 6. So it still matches. It's just relating it now to that complex number plane. So why don't you guys try 3 and 4? So for number 3, the real number piece is missing. So that means that there's a 0 there, because it's like 0 minus 4i. So 0 squared. Now the number in front of I is -4, so you're going to square -4. So 0 squared isn't going to do anything, but what's -4 squared? (16). What's the square root of 16? 4. So we should have just gotten 4 for 3. What do I put underneath my square root for number 4? 1 squared. (2 squared). What's 1 squared? 1. (2 squared? 4. So we have 1 plus 4, so we get the square root of 5.